All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the summer 2022 semester at George Brown, and it's week 14, part one of our broadcast and recording. And today we're talking about Lab 8, and then we'll be talking about tactical and strategic AI on Thursday. Okay, so this is our kind of our second last week, and we want to kind of put together things for you so that you're closer to what you need for assignment 4. Okay, so we'll talk about that just now. So last week, what did we do? We talked about utility theory and action execution. We talked about how to do that, and I'll discuss more about that on the Thursday. We Lab 7, part 1, 2, 3 was supposed to be completed by Sunday. That's when it was due. And what we're doing this week, tactical and strategic AI is what's happening this week. Lab 8, it says this Saturday, but it's actually going to be due this Sunday. I've moved it to this Sunday. And what's due? Lab assignment 4, I've moved the due date to next Monday. So I've given you an extra day. So instead of it being due on Sunday this week, it's going to be due on Monday, just to give you an extra day. Because if I make Lab 8 due this Sunday, then it's like both due at the same time. And I think that's too much. So that's why I've kind of moved it off to the Monday. Assignment 5 is due next week, and that's during lab time. So what I'm looking to see is for you to demonstrate your assignment 4 during our lab period. So this time next week, we should be in class in person. That's what I'm hoping is going to happen. That's the plan. And if that continues to be the plan, then during our lab period, so that's from, again, next week from 1 to 3 and from 3 to 5. Hopefully we can just get it all done from 1 to 3 for those people that are going to do it. Again, if it's groups of up to 3 people, we're going to do a very quick show me what you got kind of thing. You're going to do a little presentation, and I'll go through the presentation requirements on Thursday one more time just to make sure you guys have everything you need. All right, so that is assignment 4 and assignment 5. Again, this week we're sitting at the week of August 8th. So second last week. Next week is the last week. There's no exams in this course. It's just the final presentation for assignment 4. And that's what's happening. So, but we're doing labs today. And what we're doing today is we're going to make a little torpedo that fires when you press F. I was supposed to do that with you last week, but it's okay. We'll do it this week. I think it'll be unimpeded. And then the ranged combat enemy is also going to fire a torpedo at the player when they are within line of sight. A couple things for you to do for this Sunday is some torpedo polymorphism. We'll talk about what that is, as well as complete the move to player action. And I think this will be nicely setting you up for assignment 4 so that you can get things closer to where you need to be. So that is what's going to happen today. Any questions before we move on into our lab itself? Okay, I know some people want to talk after. We can talk after class. I can go as kind of efficiently as we can. And let's move towards that. So again, from a starter perspective, if you look up online, let's look there. And if you look at labs, like always, Lab 8 comes with a starter. And this means somehow if you could not complete Lab 7, that's okay, because Lab 8 is the completed version of Lab 7 for the most part. And that's where we're going to start. So please grab this Lab 8 starter if you haven't had a chance to do it, or if you have a completed Lab 7 that you submitted, you can always start from there as well to save time. It's up to you. Okay. There's the instructions that we're going to follow, and there is the lab report that's there because, again, we're only going to do a one and done. So it's a 4%er this week. It's going to be done this week and due this week on Sunday. All right, so that's how it works. Remember, what normally would happen is if we were in class, this would be due at the end of class. You get to do the lab with me. At the end of class, you submit. We're not in class 100% right now, not very much at all, and that's why it's due on the Sunday. Okay, so let's kind of get moving on this and see how far we can go. So last time what we did, and I'm just pulling up our Lab 8 starter. So again, for you guys, what you would do is I'm just going to go into our desktop and I'm just going to show you what we got. So here's what we had last time. We had lab 8. I made it out of lab 7.3, and I've kind of shared that lab 8 starter with you online. And so those are the files that I have right here that I'm working with here. First thing to always do is run the previous lab to make sure that it's functional. So let's do that. So let's run this thing and see how it goes. And as we saw last time, we have, kind of a grid that we can toggle. We also made this interesting radius. So you can see that our player is within radius, as an example, of the enemy, right? So that's why the enemy is not stopping. What they're supposed to do is when the enemy is within the player radius, but not in line of sight, they're supposed to be performing, like it says down here, the move to line of sight action. Okay, so if I was out of radius, so let's say if I pull my ship down out of radius, you can see that now as the ship is outside of radius, then as the enemy continues to move closer, when the ship becomes in radius, see how it stops? Then the enemy's job is to move to line of sight because they've detected the player, but they don't have line of sight. So from here, you can see that if you're going to complete assignment 4, the closest nodes, if you will, to to have line of sight would be either 1, 2, or 3. These nodes in here. Most likely this node right here. This is the node that you would need to go to. Okay, so I'm just pointing this out. Like if we were going to plan it out, this would be the node that I want to go to, and I want to go some kind of circuitous route around the obstacle to get to the node. That's the idea that I'd want to do, right? So, and then as soon as I'm in that position, then I would of course want to fire at the player, right? Because that's the idea here with this thing here. All right. We're not going to do all that today. All we're going to do is when the player is within line of sight, right? When the player is within line of sight, then we're going to perform the attack action. So we're going to do that. That's the goal of today. Okay, so let's clear that up. That's the goal of today, and that's what we want to do. So again, what that would mean is if I was to move my player up here, now as soon as I have line of sight, okay, so this line becomes green because I've got line of sight apparently, right? Then as soon as I have line of sight, notice it says perform attack action. So it's actually ready for us. The perform attack action is ready to go. We just haven't done any kind of attacking. And I want to show you how to create a little torpedo that fires as an example when the player is within line of sight. So that's kind of how we're going to do it. Okay, as much as possible. Let's see how far we can get. So that is our starter. And again, as always, we have a little document that we're going to follow. So I'm just going to go to the document here for a second. And under the document, we have a lab 8 instructions. You can find that in the lab itself. So if you go up online, you can see that the lab 8 instructions are here. If you want to follow it again on your own, you can do that. For the most part, they're there, but there's also the video that you can also follow. And that's kind of what I recommend. Or just, do it with me as we go. And then you don't have to do anything. Just make the video afterwards and talk about how everything kind of works. It's that simple. Okay, so things that we're going to change today are going to be the play scene.h and CPP, the range combat enemy, close combat enemy, and we're going to add new files, torpedo.h, torpedo animation state.h, and torpedo-k.h. So there's 2 types of torpedoes we're going to use. And again, we're either going to use the completed lab 7 or the lab 8 starter to get going on. So that's where we're going to go. Let's do that. And I've already got lab 8 to start, so we can do our first commit. Okay, so again, back to this. Here's our lab 8 starter, which is what we're using. And again, what I'm going to do is I'm going to use command line for the GitHub repository. For you, you don't have to do that. You can use GitHub desktop like we've been doing kind of the entire semester. So let's just go in there. And if I do a CD space, and I want to grab this whole section, which is what I'm doing. I'm adding this new lab to the section. So I'm going to say git add dot, git commit -m, and we'll say added lab 8 project files, which is what I've done. Okay, so that's it. And then I'm going to do a git push and push that up on GitHub. Remember the GitHub repository for these labs. You can always find it, right? So if you go to github.com and if you go to George Brown College, then you'll see that this GAME3001 M2022 labs repository is the repository that I'm updating every single time. All of the details on everything you need are right here. So I'm just going to kind of copy that and give you this so you have this as a reference just in case you fall behind today as we get moving. All right, so that's where it is. Okay, so that's kind of our setup, and we've done our first commit. So we've kind of passed by this one. What I want to do right now is kind of create a torpedo class, which is a sprite. Now we've kind of done this, like I said before, together. For some of you in our game production class, I kind of did a demo, and I also added a optimization pattern, which is an object pool. I don't think we'll be able to get to that today, and that's why we're not going to clean up the torpedo when we fire it. There's no cleanup. It's just going to go on forever. Whenever you fire a torpedo, see you later. Okay, so that's how it's going to go right now. Let's get into this and see what we're going to have to add in. So again, going back to this, just like before, what I want to do is I want to add a brand new game object called torpedo. We don't have one right now because we already have an example of a sprite, because a torpedo is going to be an animated sprite. The torpedo assets, and again, let me just go back to this. Inside of Lab 8, you've been given some sprites already by default, right? You've got both sprites, torpedo.png. This is kind of the required assets that you need. And it kind of looks like this. So there's your torpedo, and you've kind of seen this before, where you have a torpedo that has several frames where it's going to rotate. Again, borrowed from Star Trek. Okay, this is where it comes from. And you also have torpedo K, which is just torpedo with a green tint. That's all it is. Okay, so it's the same sequence, but it's just colored differently, so we can differentiate one from the other, and we can kind of check to see if they're both working. Okay, so that is torpedo and torpedo K. It also uses a torpedo text file, and the torpedo text file that we use when we do animations have several frames, so 8 frames of animation. So that's the name of the frame, the X and the Y coordinate, and the width and the height. Notice that our torpedo is a perfect square, 64 by 64 pixels. That's how it's going to work. All right, so that is our torpedo.txt file. We need that for any animations, and we also have examples of that for our Mega Man animation and so on, which we have kind of up here. But again, let's move on and make a new torpedo. So because we have this, we already have a player. If I look at player.h, you can see that that's a sprite, okay? And we also have a player.cpp, and that is pretty much what we need to some degree to kind of put together a little, kind of a little animation. We're not going to do something as complex as this because we only have, 8 frames of animation, and we don't have different animation states. We only really have one animation state, right? So we need also a file for torpedo animation state. Why is that? Because if I look at the player, if I was just going to use this as a prototype or a template for all sprites, you can see that we have an animation state setter that's here. And it uses something called player animation state. If I go to definition for this to show you how animations work, you can see that there are several different animations that we want to kind of trigger. And when I think about states, I'm thinking about state machine, which is kind of interesting and related to AI in some ways because we're using a state machine. We can use a state machine here. So here we have several states: player idle, player run, player left, and so on. But we only need one state for our torpedo. It's just firing. Maybe we have another one, which is loading or exploding. Maybe there could have been other states for the torpedo if we had other torpedo animations. We do not. We're only going to make one. But we need something like this for that torpedo. So I also have to duplicate our enumeration, which is called player animation state. We're going to duplicate this for the most part and make a torpedo animation state. Let's start with that. Let's start with the torpedo animation state first. because we need it. So it's a dependency, right? So I'm going to right click and I want to make a brand new item, and I'm going to go here and I'm just going to browse to the right folder. So again, I'm going to click browse. I want to go to the SRC folder where everything is going to go, select it, and this way I'm in the right spot. I want a .h, that's the kind I want. And from here, I'm going to create a brand new thing called torpedo animation state. Make sure you spell it right. .h, okay? So that's where it's gonna go, and I'm gonna click add. Because my mouse was on enums, torpedo animation state is right here, and all I wanna do is get that player animation state and copy paste for now. So copy paste inside of here. And let's change this to torpedo animation state. Torpedo animation state, okay? We also need, the reason why it's complaining, we don't have this part, sorry. So that's the torpedo animation state, but we don't need all this stuff. I'm going to talk about this in a second. This will be the torpedo animation state. And really, if you think about what that torpedo animation state is going to have, it's like fired. I fired the torpedo. So that'll be the first thing, or firing, whatever you want to call it. But for now, you might have several states. Like you could have fired, as an example. You could have firing. You could have exploded. You could have destroyed. Maybe something has destroyed the torpedo or something like that. You could have other things, gone off track, whatever. A lot of other animations that you could have had here. For all we need is one. And you need some kind of animation state for this, even if it's a single frame or single animation state itself. Okay, that's what you require. Okay, so that's save. And that is our first file. We've added our torpedo animation state. I could make a commit, but I'm not going to do that here. I'm just going to continue with the next thing, which is going to be the torpedo itself, which is a game object. So let's do that. So again, add new item. I need two of them, right? And I'm just going to go here and add the first one. It's going to be torpedo.h, right? And that's going to go inside of the game objects folder, or filter. There's one. And let's add another one immediately. New item. Let's add in torpedo.cpp. So that way we got both of those things. Torpedo.cpp. There we go. And in the CPP file, we want to reference the torpedo.h. So we're going to include, torpedo.h. Okay, just to make sure that that works. There it is. And torpedo.h, we're going to kind of copy paste some of the things. But remember what we want to do. We want to do an if not defined torpedo, right? We want to define a torpedo. And we also want to do an end if. This is kind of how we start off all the time. If I can actually spell define. There we go. All right, so that's kind of the first thing. And we also want to think about this as a class, right? Which is going to be called torpedo. And it extends what? A public sprite. That's what it's going to extend. Okay, and I can do this just by hand because I know that the torpedo is going to be a sprite, and a sprite is a type of display object, right? So it's going to include sprite.h. Now, let's pause here because those are the basics that we need. We also know that we're going to need torpedo animation state.h. Let's add that in as an include because we're going to use that. Okay. And for the rest, before we move on, let's take a look at, and we'll do a side-by-side with the player. So if I take that player, this one, and I do a side-by-side, so I can just kind of pull it here and pick this little, there's a bunch of different positions you can put it in. When you do a split screen, I want to do split screen right here. So you can see the player on one side and you can see the sprite or the torpedo on the other side. Notice the similarities right now. Okay, maybe if we were to put this up here, it would be almost identical at this as we start. Now we marked it as final. I don't have to do that here, but we definitely want the public area and a private area to be part of our sprite. We need some of this stuff, and it's identical. So let's see if we can get some of it from the torpedo itself. Because the torpedo inherits from the sprite class, right? Then we theoretically should be able to generate missing members, right? So if I do that, and if it says I want to do a draw, update, and clean, then clearly I can get those members in the public space. And these are life cycle members. Life cycle methods or functions. Okay, that's how we started off. I could have also copy pasted. I also would like the player, which is the torpedo constructor, as well as the torpedo destructor. So those are the basics we have there. And we also have set animation state as a setter, right, which is part of this player sprite. Let me see something else. We can also go here and say, like it says make torpedo class final. It recommends that. Sure, that's where this came from, right? And then it kind of goes through and says generate definitions, create this, inspection, do all these other things. What we really need is a couple of functions. One is a build animations function and this setter right here. So I'm going to grab this setter and I'll describe what the setter does again. So the setter is not going to be player animation state. It's going to be torpedo animation state. There it is. That's the new state. So that's the difference between this and the other one so far. And we also need here a torpedo animation state member variable that we're going to keep track of. So torpedo animation state, we're going to keep track of that, which is the current animation state. You can see that it's identical. There we go, current animation state. All right, and then finally the build animations method, which is part of our little torpedo and so on. Now, what we could have done inside of the sprite class, I could have made it so I could have forced you to do this, right? So like I could have made it so that build animations was a something that you have to override. Well, let's take a look at the sprite class really quickly and see what that looks like. I'm going to put it over here. So I'm going to click this side first, and then I'm going to go to the sprite superclass, which is in core. Any superclasses are here. If I double click there, it'd be nice if we thought about this, that we had a build animations method that was built into the sprite class. And this way it would be an overridden method that we could add in. Okay, that's something that we can do. It has other stuff that's built in though. It has a set sprite sheet and a set animation. So we can set up the animation and the sprite sheet, as well as get animation, get sprite sheet. We can do those things. So yes, we could have included build animations as a virtual function to overload, right? So not a pure virtual, but just something that I want to override, right? And I could have done the same thing with my set animation state. I could have made a superclass of some kind of, instead of a torpedo animation state, I could have had something else we'd have to override, right? Maybe another enumeration. It's called, I don't know, animation state. That would be an enumeration you'd have to define, okay? But for now, we don't have to do this. I'm just showing you what we could have done when we set up this superclass. Okay, that's the superclass. We're going to refer back to this in a second. All right, so great. So we've done this piece, and I want to go here and use a little hammer, and I'm going to do generate definitions by declarations. It's going to ask me which ones I want to generate. I need all of them. I need draw, update, clean. I need to do all this stuff right now, and then click finish. This is going to create stubs for all this. Here for the constructor, the destructor, we're going to make the default constructor is something that we're going to do here. We have a draw function, an update function, a clean function, and a couple of additional things here that we're going to set up. All right, cool. So that is the torpedo. Let's set up the torpedo.cpp, which is very similar to the player .cpp. So again, in here, just double click on the player. We'll just kind of pull this. Sorry, here, double click on the player. Let's see, there it is. And now we can see the player here on the right, and we'll just kind of hide this stuff so you can see more. And here is the torpedo on the left. So we need to do something similar. We know we're going to need the texture manager to draw. So I'm just going to grab that. So here is texture manager.h. We're just going to get that right away. And we're going to follow some of this stuff. Now, one thing to note is that player, what it does is, I'm just going to move this over here. Player, what it does is it sets up the default animation state to idle. And this is great. So I can do that too. So I can say something like that. So I can say m_animation state is a torpedo animation state fired, which is the default one. There's only one, right? So that's kind of where I'm going to go with that. All right, so that's kind of the same thing. All this, I'm just going to copy paste. So I'm just going to grab all this. So it's a bit of a copy paste exercise, but I'm going slow here just to describe what's happening. So the first part is I want to, remember, for any animation or a sprite, we need 3 pieces of information. The sprite atlas itself, which is this file, the texture file. We also need the data file, which is in for the other one, we had it called atlas.txt. And finally, we have a sprite sheet that we're going to kind of, we're going to name it something, and we're going to hold it inside of memory. All right. So that's kind of where we're going with all of this. And we're going to kind of, duplicate some of this stuff because we want to get, a lot of this stuff to be the same. So we know that the sprites, that instead of Atlas, it's called Torpedo. I just showed you that earlier, torpedo.txt. So that's what that's going to be. Instead of our PNG that we're using here for my player, I'm going to use the torpedo.png. So that's what it's going to be called. And you know what? As a friendly sprite sheet, instead of, because we already have a sprite sheet called sprite sheet, here we're going to call this torpedo sheet. So torpedo sheet, there we go. So torpedo sheet is something that we're going to know. That's going to be the name of our sprite sheet. And what we need to do to make this work is we're going to use the set sprite sheet method that's built into all sprites to assign whatever the sprite sheet is to my sprite. So here I'm just going to call this the torpedo sheet. Okay. And that's where we start. So again, I'm just talking similarities. Here, set width and set height is 53 and 58 for the player. That was Mega Man. Here, we're going to make it so that it's 64 by 64. Remember, because 64 by 64 is what we saw when we looked at the data. So if I looked here at the data for torpedo.txt, you can see that that is 64 by 64. And so that's what we're aligning the width and the height of this stuff. That's what we're doing here. Okay, positioning. Where this starts, it doesn't really matter in terms of a default position. Here we started the ship off at some default value, and really at the end of the day, we can keep the same. Clearly, the type that we have here is not a player, right? Could there be another type? Let's see if there's something else that we can use. And you can see that there are a bunch, right? But none of them makes any sense. So agent, back button on, blah, blah, blah. It's not an obstacle. It'd be nice if we had some other kind of type here, like a projectile. So let's make a brand new type here. So I'm going to go to definition for the set type, and let's change this thing to projectile. Okay, so that's what it's going to be. Projectile. We could have also called it torpedo. That would have been also reasonable, right? Save. So that's game object type we just modified, just so that way we have a type we can define here. So I can just use projectile. There it is. Right, so now it's a type. We know it's a projectile type, right? And we have a build animations call. This is going to call the build animations method inside the constructor function when the constructor is called. Okay, so that's what it's looking like. So it says, always initiate member, blah, 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 and it doesn't say anything else over here. So let's go down and compare to the right. We have a torpedo. We have our torpedo. Here at the right, we have a set of animations that we're going to draw. And this is okay if we had multiple sprites that were, or multiple, states that we were going to go in. For example, if I was in different states, let's say I had, just like the player has an idle right, idle left, a run right, and a run left. If I had some stuff that I could draw differently for the torpedo, then I might need a animation state. Now I'm going to build it in because I think it's a good idea anyhow. okay, just from the get-go, I think it's a good practice to do something like this. Okay, so let's just do it because we're going to set up for it. So we're going to do a switch case, and we're going to put in M underscore current animation state. We're going to switch, and I'm going to say case, and we're going to look at fired because it's the only case we can kind of have right now. But maybe we'll have other ones in the future. You know, we're going to do something inside of there, right? And normally, what we do is we use the texture manager here to actually output what's going to happen. Let's just do the same thing. We'll do a copy paste here, and I'm just going to go over here and let's define what all of this does. So I'm going to say, okay, instance play animation. Instead of sprite sheet, that's this thing, we're going to use torpedo sheet that we've defined here. Here's torpedo sheet, and it says get animation idle. Well, that animation doesn't exist. We're going to make one that's called fired. So we're going to make that. We don't have it yet, but we're going to. It's going to be called fired. All right. And we're going to use the position that we're going to do. So get transform position for the X and Y coordinates. We have a speed factor. I'm going to set that speed factor right now to 5. That's how fast the animations are going to play, right? Angle, alpha transparency, and is the actual object centered or not? And that's it. Now, to take away some of this, the switch case, we could also have a default case. This could be the default case, actually, right? If I had a default case, I can include it here as well. And the default case is something that would run if it's not something else. If it's not fired and if it's not whatever, then that's the default animation, right? Truly, this should be the default animation because there is only one, but we're going to leave it like this. All right, update. Let's take a look. So we've kind of gone through one thing at a time. In our update function, what does that look like? Well, update is kind of empty right now, right? Why? Because update doesn't do anything for the player, right? We haven't made it move or whatever. But for us, we're going to make it move. Let's make that happen. So we're going to say something like, hey, get transformed position. And what we're going to do with it on the x-axis is we're going to add on the speed object. We want to add some kind of speed to this thing as well, right? Now we don't have a speed because we're just copy pasting, but at the end of the day, it'd be nice if we had some kind of speed as well. Well, that kind of says that I need, I got a need for speed. Oh, so here what I would do is inside of .h, let's add it in. So I'll say something like, hey, I want a floating point value data member called speed. There it is. Maybe I could have getters and setters for this. I'm not going to do that just to keep it simple. And let's go back to our torpedo constructor function, and we'll also initialize speed as some default value. So again, I'm going to, whatever the speed is going to be is what I want. And you know what we could do? We could have that inside of the constructor function. Going back to the torpedo.h, just as I'm thinking about it, I'm thinking, you know what? In the constructor function, let's give an optional speed value. So I'm going to say float speed, right? And we'll say it's optionally going to be equal to 0. So by default, there's no speed value. But when we're constructing the torpedo, we can assign a speed to the torpedo itself. I want it to go faster or slower, like the actual locomotion, not the animation speed, but how fast it travels across the string. Okay, so that's what this is. So that's the torpedo speed. And similarly, what I want to do here is, because now we can put that in here, I know that the torpedo.cpp can also have this. So this is a float speed. That's what's going to be up here, right? And then what I can do is I can initialize the speed m underscore speed to whatever I get in from the constructor function. So this is kind of like initialization syntax as an example for the constructor. So we have a speed variable. And now that we have a speed variable that we initialize when the constructor is called, scrolling down, we can now use it here in the update function. Okay, so that is up to date. Yay, cool. Clean is just going to be empty for now. We're not going to do anything. Set animation state. That's pretty easy. It's a setter. We're just going to say m underscore current animation state is equal to whatever that new state is. just in case I wanted to have a change of animation state. That's the animation state. We can also make this const because we're not going to change anything by default. Okay. So far, so good. Where the real business happens is here in build animations. We want to be able to build this fired animation, right? We don't have an animation, and this is something that we want to be able to do all the time. And we have an example of it right here when we build a brand new animation. So let's use this as a example. Well, only one, we don't need both of them, because here we have two animations, right? We have an idle and a run. I only want one animation, which is just a fire. So I'm just going to take the idle, copy it here on the right, and go to build animations here on the left and paste it in. Now, clearly, it cannot be called idle. It has to be called fired. Well, it doesn't have to. You can call it whatever you like. I'm calling it fired because it makes sense. Okay. And then it says get sprite sheet, get frame, and it's called Mega Man Idle 0123. What do we need to put here for us? Well, this Mega Man Idle 0123 is what we got from our Atlas. Here, remember, for Mega Man, we're loading the Atlas sprite sheet, right? So it's the atlas.txt. That's what we're loading, this one. This is the Mega Man sprite sheet. Notice that the names here, Mega Man Idle 0, Mega Man Idle 1, 2, 3, and so on, these things are all the frames for Mega Man. And I know that Alex has gone through this with you already, but here's another example for us. So then our names are going to be fired 1, 2, 3, 4, 5, 6, 7, 8. Fired is what it's going to be, right? So, okay, so that makes our job easier. So it's fired, and we're going to start at fired 1, fired 1, fired 2, and so on. And I'm just going to copy paste that first line over and over again. So we don't have to, I'm just going to replace all those. Oh, yes. And we're just going to make it fired 2, and it's all the way up to 8. Okay, so 2, 3, 4, 5, 6, 7, 8. Okay, I'm just going to make this a little larger so you can see it over here. And this is what it would look like. So 2, 3, 4, 5, 6, 7, 8. Just copy pasting and change the numbers. So where am I getting this again? I know all these people are confused about this kind of thing. It's not that difficult. It's just here's in torpedo txt 1, 2, 3, 4, 5, 6, 7, 8. That's the name of the frame. Okay, and then what it does is our subsystem that I built for you guys. It goes and looks in the sprite sheet at X and Y coordinates for where that particular frame is, and for this width and height, and it's the one that's going to be rendered. That's the frame that's going to be rendered that particular time. Okay, so that's what's happening there. So this is our fired, and this won't be called idle animation. Let's refactor rename. So we're going to go refactor rename, and we're going to rename this to fired animation, just to make sure that it matches the name of our animation state, right? The fired animation there. Hey, look at that. It's called fired, and we have a build animation, and that's it. That is our new sprite. We just made a brand new sprite called torpedo, and that's all it does. Nice and easy, straightforward, that kind of stuff. Let's put this up on GitHub. We haven't tested it yet, and we're going to do that next. So we're going to put this up on GitHub. So just like it says, we made a torpedo class, and I'm just going to pull up our terminal window, git add dot, git commit -m, and we'll say added torpedo sprite and related stuff. Git push. Notice that it needs 3 files, the torpedo.h, torpedo.cpp, and torpedo animation state.h. Nice. Questions around this? Any questions around what sprites are, how to use them, all that stuff so far? If you do, this is the good time to ask those questions. I'm sure it's review for some of you. Marco says you're good. Thank you, Marco, for that feedback. And so is Vander. But it should be very straightforward. You should know how to do this. Again, I'm putting this together for people who have forgotten, don't know, can't figure it out, all that stuff. Okay, so wonderful. So now that we have this, let's just close off the player here so we don't need the extra split screen. let's pull up our Solution Explorer again and pin it. So that's what we're going to do up here. And then what we want to do is we want to test it inside of the play scene. So I'm going to go to scene, play scene, and here's the .h, and here's the .cpp. We're going to bring all those things in there. I'm going to just hide the player animation state for a second, and I'm just going to go over to the play scene.h first. So for the play scene to fire a torpedo, when I press the F key, I'm going to press the F key and I want the torpedo to be fired. Okay, that's how it's going to work. And it's just going to fire in, I don't know, a direction that I want it to go in right now. So I need a couple of things here. One, I need access to our torpedo itself. So let's include it. There it is. So I have torpedo. Awesome. Next, for Lab 8, notice that I have all this stuff and we're adding in different pieces to it. We have our player and inputs and all that kind of stuff. And I want to be able to add in some game objects. We have background, a target, a ranged combat enemy, and a close combat enemy. Wow, let's add in some sprites for everything else. So that's going to be let's suppose before this vector over here. So here I'm just going to go here, and I want to make a brand new vector of torpedoes. So this is new for Lab 8. And what I'm doing is I'm saying, hey, let's make a standard vector of torpedo pointers. Torpedo pointers, right? Vector is a collection of torpedoes now, and it's going to be called m_p. So a member variable that's private, that's a pointer called torpedoes, like potatoes. There we go, torpedoes. That's the vector. Okay, and once we have that, it's going to keep track of all the torpedoes that I have here, and it's just a container. Now, I don't really need this torpedo vector. I don't need it because I'm not really doing anything with them. I'm not cleaning anything up or whatever, but this might be a good start if I was going to create some kind of object pool, right? Because I need some kind of collection. For now, not going to do that, right? So let's just put this in here, all right? Next part is I want to, so that's in for the, the play scene, that's what I require. Let's go to my play scene.cpp now and make some changes. So let's jump to the start method. So here's my start method. And in the start method of the play scene, so we're going to go to this. Then let's rename it. So it's going to say, it's going to be Lab 8. There is no part 1, 2, 3. It's just one part for this one. And for when we start this off in the start method, we need some place, right, as an example, to do something. So remember, we can't fire a sprite unless, or do anything with it unless we have some kind of stuff that we've set up. So far we've got our, just to go over, we have input from our keyboard or mouse. We have our background image that we have. We have a target and a ranged combat enemy that's by the default what it is. We also have, we've set up things like line of sight mode, and coming down to the bottom, what I want to do is I want to preload some sounds. Right now we have a yay sound and we have a thunder sound. Guess what? I want to load up a torpedo sound. Where is that? Well, if I go back to my project and I look at assets audio, then we have different kinds of sounds. One of them is the torpedo.og file that we're going to use for this one. All right, this is the one we're going to use, torpedo.og. So let's just copy paste a sound effect. So here's their sound effects. And instead of it being assets audio thunder, we're going to say assets audio, and it's an OGG file, torpedo.og, OGG Vorbis. All right, the name would be torpedo. That is the one we're going to make, the sound we're going to make when the torpedo is fired, right? And that is the sound effects. I'm preloading the sounds because it warms them up so I can use them later on. So it's almost like pre-warming, if you will, okay? I've also preloaded music from before, and we're playing the Klingon background music. We can use other background music as well. In the past, we used something called Mutara. for the background music as well. All right, so that is our preload. Now, where we're going to fire it? Well, we know a couple things. We know we're going to have to fire something, and we know we need to update stuff. So when the torpedo is running, we have to call its update method. Well, and we need to add them into the scene somehow, right? So we can do it in one blow. Instead of doing it in start, I can do it in the handle events method. So notice that, again, if I can just jump there, handle events. So handle events, it has two types, right? It has other methods that are called get player input, get keyboard input. Okay, so if I go to, get keyboard input, so go to definition, there it is. Here's my get keyboard input, and I have some default keyboard input right now. One is the K key, which actually does damage, right? The R key, which resets, that's from last day. And I have other events that we can do as well. And one of them is going to be the F key, where I press a key and then I can fire our torpedo. Let's just do it in order. So we'll just kind of do it up here. And we'll say if event manager instance, so it's going through the singleton process. I'm going to do a key pressed, which is the SDL scan code F. That's what I want to use. That's the F key. And then what I can do with this one is I can define what it's going to do. So the torpedo will fire when I click the here where I'm going to do it. And I can just say something like in one blow, M_P torpedoes. Here's my torpedoes. And I want to push back. I want to add in a new torpedo. There's my new torpedo, which it's going to initialize the speed at 5, kind of pixels per unit. And so this is going to instantiate and add, the torpedo to the array. Instantiate a torpedo and add it to the vector. Add it to the vector. Okay, that's what it's going to do. So kind of a one and done. Okay, this is not what we want to do if we're setting up an object pool. Object pooling is different. M_torpedoes, we're going to say from the back, whatever we've added in, we're going to get transform dot position, and we're going to say that that's equal to M_P target, whatever the target is. That's our ship that we have right now, our little enterprise. Target dot get transform dot position. That is where the torpedo is going to start from, plus some kind of width or height. You can add that in here, but this is kind of like the initial position of the torpedo. We can also think about this as the spawn point. This is the spawn point of the torpedo. All right. And then we're going to say, hey, sound manager, I want to play a sound. There it is. Here's my play sound. And what sound do I want to play? Well, it's going to play the torpedo sound that I defined below, right? So this is, again, play the torpedo sound. Okay, that's what that's going to do. And then I'm going to add child the torpedo, M_P torpedoes dot back. So, the one I just added. And we're going to put it on a layer. Let's put it on layer 2. Doesn't matter. We can decide which layer we're going to put it on. So this adds the torpedo to the scene. And this is kind of a really rough way of doing it because I'm not managing the torpedo in any way. The torpedo can go off screen and it's gone. It's going to keep going forever, right? So we can have a memory leak happening right here. But all we want to do is test out our torpedo. Does it work and does it animate? That's what we want to do here. Let's try this and see if it works. Did we miss something? Let's try it out. So here we're running it. And again, if we press the F key, the idea here is we want to make that torpedo fire. If there's an error, here's the time where we're going to take care of it. Now, I've gone through this detail with you because I know some people are still sketchy when it comes to their knowledge around animations or sprites. And that's why I wanted to talk about how we did this in a very step-by-step manner, right? I mean, hindsight being what it is, this could have been handled in your fundamentals class, or whatever, like this, but it's okay. We're going to do it together here. All right, so now here's the spaceship, and I press the F key, and there's my torpedo, right? Notice it fires underneath the spaceship because I've layered it so that it's underneath the spaceship, right? So again, you can see here, that's the torpedo, and if I fire multiple times, it's going to fire and make the sound. You guys can't hear it, so let's make it so that you can. I'll share the sound, and then let's try that again. So you should be able to hear that now if I press the button. It's going to be pretty loud for you too because there's no volume control. There you go. That's how it looks. So good. And that is our torpedo. We modified our scene, and we're basically down to this part right here, okay, where we modified our play scene so that it works. Great. So we've done all this stuff. Let us put this up on GitHub. So going here, we're going to say git add dot git commit -m. We'll say added torpedo firing to the play scene. Questions so far? Any issues with this method? And I know that there's what I want to do, I want to talk about this with you guys because some people are still unsure about how all this works. How do the actual animations work? How do I trigger something? And so on. If we have time later, we'll redo something like a object pool if we have time. It probably won't, okay, because we have lots to cover still. Any questions at all before we move on? I know some people have asked these before. So you guys are all good? If you are, wonderful, right? I'm happy that you're all good. Okay, Vander says you're good. Derek is good. Good to see you, Derek. But it's pretty straightforward, I think, and you guys should have known how to do this, again, for a while. Marco is also good. How about the rest? Ali, and I see Kayla and Graham and Jaden and Kieran. You guys okay too? Ali's good. So Marco, how are you doing? Jaden's good. Okay. So I'm just checking with you guys because I want you guys to understand how this works. Okay, thank you. All right, so I'm just going to clear all this one. Thank you for the feedback. Hopefully you guys got how to do that. And again, it's up on GitHub, so worst case scenario, you're kind of good to go. All right, so now the next part. This is the hard part. We've kind of added in our own torpedo, but what if I want to make a brand new torpedo class that is fired by the Klingon ship? Remember, the Klingon ship is the thing that is our enemy right now, right? Our enemy ship is here. This is our, kind of our ranged enemy, or this is, I'm not sure, but we want to make it from our, we'll swap it out so we can say that the ranged combat enemy is actually going to be the Klingon ship as well. So the Klingon's going to fire at us, okay? So instead of it being the NCL, which is what this is, we'll swap this out inside the scene. There'll be both Klingon ships, okay? Both the close combat is a rammer, it'll ram into us, and the ranged combat enemy is going to be firing at us, okay? Different kind of ships, let's say, but we can just change that up. So again, the ranged combat enemy is what we want to change. So where we would go is, if we look here for decision, if you go to decision, and if I go to ranged combat enemy.cpp, that's all we're doing is swapping out the animation, right? So that's something that's simply done because we don't need to really do much here with this. So we're going to swap out, instead of Reliant small, we're going to swap this out for D7 small. D7 small, that's the ranged enemy. Everything is going to appear the exact same way, but this is the first change we're going to make. Okay, so that's the first thing. And let's run this thing now so we can see how this all works. And we're just going to run it. And now we see the Klingon ship. That's the guy that's going to fire bullets at us now, okay? So that's going to be like the good guys. These are the bad guys, all right? At least in this scenario. in other scenarios and from the franchises and everything else, they're all good guys. All right, but right now, these guys are the bad guys. Okay, awesome. So, that's the first part. The next part is I want to be able to, so again, going back to this, we want to make it so that we need to make a new torpedo to trigger. All right. All right. So, your job is to use polymorphism. So if you actually look at what yours to do, you have some to-dos today, right? One of these is torpedo polymorphism. It says rework the torpedo classes so that there's a torpedo base class and 2 subclasses. 1, torpedo federation for the good guys, and 2, a torpedo Klingon class for the bad guys. 2 different kinds of torpedo classes. All right, so I'll talk about this in a second, but first things first, let's make a copy of the torpedo that we already have, and we're just going to call them Torpedo K for Klingon torpedoes. All right, so making a copy, not really recommended. It's better that we inherit if we can. It's like a torpedo, right? But how do we do this and what do we do? So is there a way to copy paste, this kind of thing? Well, you can't copy C++ within the project, right? But what we can do is like what we did before is if I want to show my folders. Here's my folders. Let's go back to Lab 8 SRC. And then what I want to do is down in here, I want to grab that torpedo and copy paste it to torpedo K. Nice and easy. So grab these 2 things, copy, paste, and then rename these things torpedo K with a capital K. There's different kinds of torpedoes. For example, in the franchise, if you know anything about the lore, then they're photon torpedoes, and there's also, disruptors is what they use, right? So that's kind of like what they kind of had. They have Klingon torpedoes, but that's kind of what we're looking at there. The animation is not exactly correct. Who cares? So now what we want to do is I want to add existing item, and I want to add those torpedo Ks that I just made. So I'm going to go back to maybe look at the right folder. There we go. And I want to look at torpedo K, and I want to add torpedo K into the game objects class, all right? The game objects filter. So torpedo K is identical in every way to torpedo, the regular torpedo, except it's going to be green. Like there's no other difference between one and the other. So why would we bother, right, doing it this way? Well, let's just rename torpedo to torpedo K. So we need the torpedo K here, and here, and here, and up here where we have torpedo, we're going to say torpedo underscore K because we want them eventually to do different damages. They have different, maybe they have different properties. Right now we don't really have different properties. And our old torpedo didn't really have a lot of things that it could do. Our torpedo K is also going to have a direction that it's going to keep track of. Before, all we kept track of was speed. I couldn't fire my torpedo in a particular direction, but it'd be nice. So this is kind of the version that if I had the ability to fire my torpedo in a direction, how do I do it? Well, first we need a direction, GLM vec2 object, that is M underscore direction. All right, so that is something we want to keep track of, the direction that this torpedo is moving in. Okay, and then inside of the constructor function, let us set it up so that we can say that we have a GLM vec2 object called direction that we're taking in, and by default, we can initialize it to something like 0, 0. So we can initialize it right here. So we're kind of initializing our torpedo, right, to, yeah, like this. And what this does is it initializes the torpedo so that there is no direction right now. We're going to set the direction, of our torpedo when we're firing. So this is something that we want to do for our torpedo K. So that's where it's different. Torpedo K, torpedo are the same, but it has one extra thing, one extra property that we're keeping track of, one extra piece, which is the direction that it's firing in now. Okay, so you have both examples. Sometimes you only want torpedoes to fire in a certain one direction. Like let's say bullet rain, maybe it'll fire down at you in one direction. You don't care about it going in different directions. But here we want the torpedo to have that property, and that's what we're going to add it in. Okay, torpedo K dot CPP. Let's rename everything so that the torpedo K is using torpedo K everywhere. So let's just find that everywhere we want to do. So again, I'm going to go kind of control F. I want to find, actually, let's just be smart. Control F. We're looking for torpedo and we're replacing it with torpedo K. Guess what we're replacing it with? Replace all. One thing that happens is when we do such things, it's also going to replace things we don't want, but we're going to go back and fix this in a sec. All right, so again, it's not going to be torpedo K, it's torpedo K, kind of lowercase, that's up here. I mean, it doesn't really matter. Torpedo K has a float speed, but also has a GLM vec2 direction. That's what it does. It takes that in. And we're not going to set up our animation state differently. It's not going to be called current animation state, torpedo animation state, torpedo K, kind of stuff. There's only one. It's called torpedo animation state that we're going to be using. And the same thing goes there. So that was just something that happened when we kind of replaced everything, right? Which is not what we wanted. The torpedo sprite sheet is going to be the same. It's going to be named the same because it actually is identical, right? And torpedo K is the object that's going to be, we'll leave this as lowercase t for torpedo. And our sprite is going to be torpedo underscore K. That is the name of the sprite that is going to be, we're using. And that we have to call this something different. So it's going to be called torpedo K lowercase k sheet, torpedo K sheet, which is what I'm going to copy paste here. So far, it's the exact same. There's no difference, all right? So that's good. The frames are the same. All this stuff is the same. It's still a projectile type. However, the direction, right, is something that we can set up here. We can say M underscore direction. Well, that is equal to whatever the direction is, the current direction is, that we set, multiplied by the speed factor that we're going to get in from our constructor. And then we can also say that the direction direction.y multiplied by the speed, that makes up the direction of our torpedo by default. So this is a way of initializing. Other ways of doing the exact same thing is we could have done something like this. We could have said M underscore direction is equal to a new GLM vec2 object where we pass in the direction dot x multiplied by speed and the direction dot y multiplied by speed. So that is the same thing as this, okay? Just in case this is just initialization syntax, but it's identical because M underscore direction is a GLM vec2 object. We can use initialization syntax that does this. Okay, so that's just another way of doing it. All right, so yes, we've initialized everything. We've got our torpedo K sheet. We're going to have a torpedo lowercase k. Make sure this is all spelled correctly or it won't fire. And that is also correct. Torpedo K sheet is going to be fired, right? It's going to be fired. It's all the stuff is exactly the same. There's no difference in terms of, its state because we're using the same state that we had before, okay? In the update function, that's a little different where we're going to say that the position is not equal to the speed, but actually the direction vector, M underscore direction. We're going to add that in, right? And and we're not going to do on the x-axis only. We're going to add it to the entire position vector. So the position vector, we're going to say, let's add the direction vector every frame. So whatever that direction vector was when we instantiated this object, it's going to keep going in that same direction. That's what it's going to do, okay? Set animation state. This is just a copy paste error or whatever. It's just torpedo animation state. That's what it's supposed to do. That is identical. Fired is exactly the same. So there's nothing that's changing here at all. So really the only thing that's different between our torpedo K and our torpedo is that it has a direction vector that it keeps track of. Okay, that's the only thing it keeps track of. So then again, let's put this up on GitHub because this is our torpedo K. Let's do that. So git add dot, git commit -m, we'll say added torpedo K, git push. Everything else remains the same. Wonderful. Now, one thing to note is, again, we pre-warmed our torpedo in our play scene for how it makes the sound, right? A torpedo has a certain sound, and we want our torpedo K to have a different sound. Again, this comes from, if you look at our lab 8 under assets, you can see that under audio, we also have a torpedo K sound, which is different than a torpedo sound. Okay, those are the two differences. So let's make that change in our playscene.cpp. So in our playscene CPP, I'm just going to jump to the start method and scroll all the way down where we're pre-warming or preloading our sounds. I'm just going to preload that one too. Let's preload our torpedo K sound, right? So again, this will be torpedo underscore K, right? And from an OGG file perspective, it's the same thing. It's just going to mirror what the OGG file looks like. So we're pre-warming this too. So we've made that one change to the play scene. Torpedo now is going to make a nice sound. Okay. But now is the next piece. And now that we've added a torpedo and modified our play scene, what we want is when we want to do the attack action, that's what we want to do, the attack action. Then when we do the attack action, I want my ranged combat enemy to actually do the torpedo firing thing, right? I want to fire a torpedo. And the torpedoes that I'm going to fire are going to be kept track of in the play scene again, right? So let's go back to the play scene.h to prepare. So we made a vector of torpedoes, and now what I want to do, again, in this particular way of doing things, this is maybe not the only way or the best way, we want to make another set of vectors, but we want to make it a vector of torpedo Ks. So in that case, we need to include the torpedo K here. So torpedo K.h, there it is. And that's a different kind of torpedo, the green one instead of the kind of the other one that we had. And down in here, we're going to make a new vector of torpedoes. I'm going to copy paste this one. So copy paste. And we're going to call this torpedoes K, the Klingon torpedo types, right? Klingon torpedoes, regular torpedoes. And this is going to be of type torpedo K pointer. So that's the difference. So there's two vectors now we're going to keep track of. One for our player and one for us, for our enemy, the enemy. All right. And that's excellent. So, okay. So now that we have this, how the heck do we add our torpedo to the scene? It's almost like we need to have a scene reference. If we're going to have the scene manage the torpedoes, as an example for now, then we need to have a scene reference somewhere in the ranged combat enemy. When the ranged combat enemy comes onto the scene, then they're going to be having a scene reference, right? And that's something different that we don't have right now. So again, in decision, let's go back to our ranged combat enemy.h. So under agents, ranged combat enemy.h, here it is. What we want for the ranged combat enemy.h and CPP is we want them, both files or both types, to have a scene reference. So that way we can say, okay, when we fire a projectile, we want to add it to whatever scene we're going to add it to. So here, again, where we say scene, we're going to say, let's make it a scene pointer, right? So range combat enemy now is going to get a scene pointer. We never had that in the constructor function before, right? Cool. Let's go to the range combat enemy.cpp, which is now broken, and fix it. It's broken because we've changed the constructor. So here, again, we're just going to say that the scene, it's going to get a scene pointer called scene. And that scene pointer is something that needs to be initialized. So we're going to initialize scene that way. And if we're going to keep track of the scene, we need to keep track of it somewhere in some kind of, property, right, or field. So let's go back to our range combat enemy.h and where we need to keep track of the scene property, right? Because otherwise there's no scene. So down in here, way down in here for lab 8, let's add a couple of different things. We know we're going to need some stuff to be able to fire the torpedo. One, new for lab 8. We need an integer to keep track of the counter. We'll call this the fire counter, right? And this is going to be the number of frames that have elapsed. So we're going to count frames a little bit. And we're also going to have underscore fire counter max. And we're also going to have some kind of frame delay because we don't want to be able to fire. Remember, before when we were firing torpedoes with our finger, I was pressing the F button. So now there's no F button for the enemy to fire. And if we don't give it some kind of delay, it's going to fire nonstop, like a big hose of torpedoes. We don't want that. We want it to fire every other frame or every 10 frames or 20 frames or whatever that is. That's going to be the delay. And then finally, we need a scene pointer to keep track of where the torpedoes are going to be added to. What's the scene that we're going to add the torpedoes to? So those are a few things we want to kind of initialize, okay? And that's going to be in the range combat enemy.h. Back to the range combat enemy.cpp. Now that we have those two things, we need to initialize, the rest of it. So first, what I want to do is I want to set those up, and I want to set them up in kind of a different order here. So I'm just going to go comma and the next line, just putting them over here so you can see them. Right here, I'm going to say m underscore fire counter. We're going to set that up to 0. We're also going to say fire counter max. We're going to set that to 60. So we're going to say every 60 frames. That means like once a second, we're going to be able to fire. And then m underscore p scene is going to be whatever the scene is that we pass into the constructor function. And let's just do one of these. There, I meant to do that. Okay, so that is the constructor initializers up here. This is a good way of doing it. And we have the rest, as you know, is the exact same. We haven't changed anything. We have set current heading and all this kind of stuff. The action state we set up as no action. We pushed back the patrol path. We did that kind of stuff. We set the target position, as an example, which is where we're going to move to. That's inside of the build patrol path. We set the type to an agent, right? These are all things that we did. We also built a decision tree in lab 7 part 2. All that stuff remains as is. Okay, so no issues there. We have our destructor function, no changes there. Our range combat enemy, in terms of how it's going to show it up and all that stuff, all the same, no changes here at all. The update function, we're making a decision. Okay, so we're making a decision. We have get max speed and turn rate and acceleration and a bunch of other stuff. And we're going to come back down to seek. Here we're seeking where we're going and so on. We have a look where you're going method. And then we might also build in a flee method, which we don't have. But that would be nice if we had that flee action that we built in. We have move, right? And we have a bunch of actions. Here's our flee action. It doesn't really do anything right now. It just basically sets up a flee. Here we perform flee. If we had something like that, uh, it wouldn't be called flee. Maybe it'd be called something like, flee action, whatever it is what we want to do, right? Because the flee action is what's going to happen. Maybe the flee action algorithm is what we would do if we were going to do the flee action. You can't call flee itself because that would be bad. We have move to line of sight, which is, this is what you need to do, right? So this is for you to do. Sorry, not move to line of sight, move to player is something that you want to be able to do with the other one, right? So some kind of move to line of sight or move to player. These are things that we haven't completed. We have a move to cover, wait behind cover. We also have our little attack action. This is what we're going to change right now. Our attack action is where we're going to, kind of make it so that it can attack when the player is, does it better that register observe about counter from scene, not directly access the scene? You want to register a counter from the scene. Yeah, I mean, there's lots of ways to do it, Derek. Tons of ways. I'm just showing you really simple. Is it better? I mean, look, it's better not to fire bullets from the way we're firing bullets too. It's better to fire a bullet from a bullet manager, or some kind of, and better that the bullet manager uses a factory method pattern that kind of creates any bullet that I want, whether it's a torpedo, phaser, something, whatever I want, right? But yeah, there's always better methods. But I'm glad that you saw it. Thank you. All right. So here in my attack action, right? So when I get the state, this is a great place to initialize, right? This is the stuff that I would do, right? So here, what I have is my action state. My action state is, the attack action. So this is where I set my action state to the attack action, right? And when I'm attacking, right, what I want to do is I want to initialize. So here I can do something like, here's actually what I'm going to do. So initialize, I'm getting ready, basically. So I'm going to M underscore my fire counter. I'm going to set that back to 0. Let's make it so that we start over again. And that's the kind of the first thing that I want to do. I want to initialize the action that I'm going to take. Okay, so now that's kind of new for Lab 8. But here's the real stuff that we're going to do. So here's the attack action algorithm. And this is new for Lab 8. All right, this is what we're going to do. I want the target direction to be a GLM vec2. So let's make it so it's a GLM vec2. And I want to calculate what that is, the target direction. Okay, so the target direction is going to equal to a util normalize. And I want to pass in, and this is the beautiful thing, hey scene. Remember that scene that I want to use? And oh, this is another thing that we want to do. Sorry, let me back up here. So if everything is good at the beginning, what I want to do is when I get into my attack action itself, I want to set the scene. So I'm going to say, hey, I want to make sure that the scene, we're going to make a scene object. We're going to cast it as a scene. We can use different kinds of ways of casting it. So if I said, if it's equal to MP scene, right? Well, we don't know what the scene is, right? Scene, if it's a scene type, it could be I don't know, because remember, I could use my ranged combat enemy in any scene I want. We need to specify what scene it is. It's the play scene that we want. Okay, that's what we want, right? So, so here I could dynamic cast, and I can dynamic cast the scene as a play scene pointer, right? And that's what this is. So I can kind of do one of these. And once I've dynamically cast the scene as a play scene, right? So I can say that, and I can get, basically I'm just creating another little variable that I'm going to use almost like an alias. This is an alias that I can use here. And what I want to do is I want to say, hey, scene, I want to get the target. So I want to get the target transform, get, and I want the, I want to get the target, and from that target, I want to be able to set the transform of the target object, right, and all that kind of stuff. Okay, I don't have a way of getting and setting the target. I don't have a way of getting the target from my scene right now. So let's just comment this out because that's what I want to do. So my intentions, here's my intentions, is we need to get the target from the play scene. Okay, that's what we need to do. The target object is what it is. The target object is what we need. I don't have access to that thing. And remember, because the target is M_P target, it is private. Okay, back to the drawing board, back to my placing.h. So then, again, I want to make a getter, right, placing.h, in order for me to get the target and all that kind of stuff, because otherwise, well, I won't be able to do that, right? I won't have a way of, of doing that stuff. So again, this is inside the public area here. I want a couple of things. I want to be able to have the target that I want to do. So I want to say target pointer. We'll call this get target. We'll have this in the play scene, and it will return a const object. That's what we need. We also need a spawn enemy torpedo. I want to spawn the torpedo in the scene. I don't want to spawn it from the enemy. I want to spawn it in the scene itself, right? So I want to make a void. We'll call this spawn enemy torpedo. Okay, that's the enemy torpedo. And those are the two methods that we're missing that we haven't been able to do yet. Okay, so, all right, cool. So I've got a couple of things. So again, this is new for lab 8. New for lab 8. There it is. And let's instantiate these two things. I'm going to go here and I'm just going to say generate definitions by declarations. I only want these two things to be declared now. New ones in my placing.cpp. Finish. There they are. So let's do each one at a time. Let's get to that get target first. So go to definition for my get target. And what I want to do here is I'm just going to simply return, it's going to be a read-only method, return a reference to the target. So that satisfies my requirement for the range combat enemy. The other one is spawn enemy torpedo. All right, so this is a little bit more involved. All right, so what I want to do when I'm actually spawning the torpedo is I want to set the spawn point, right? And I'm going to say the front of the D7. Again, is this the only way to do it? No, it's not. Just to Derek's point, we could also have had some other spawn point that's part of the, like kind of a torpedo spawn point or a bullet spawn point or whatever that is. That's also already set up in the range combat enemy, right? So that's where it's going to be, right? And so we'll just call this the spawn point here because we're going to do it a little bit fractured. And M_P starship is what I want here. That's going to equal to the M_P starship get transform dot position, and I want to add in the M_P starship dot get current direction, right? And multiply by something like 30. All right, so that's going to be the just kind of in front, 30 pixels. So wherever I'm looking, in front of where I'm looking, that's where it's going to be. And that is this part right here. That's the first part. The next part is I want to set the direction of the torpedo, right, which is normalized with the unit vector. Remember, we talked about this before, the unit vector value, which is, 1, a value of 1. Okay. And we're going to say GLM vec2, that's going to equal to the torpedo direction. Okay, we're going to call this. And that's util normalize. I'm going to pass in the M_P target. There's my target. Get transform dot position, right? As an example, minus my spawn point. So that's going to give me the direction of my where I'm firing. That's the direction of my torpedo. And then let's spawn the torpedo, and similar to what we did earlier when we fired the other one in the we kind of did that up here in the method. And by the way, range combat enemy, the reason why range combat enemy is having a problem now is because we've modified range combat enemy to have a reference to this. It needs a reference to the scene, right? That's why it was causing a problem. That's why it was showing up as a problem, because we modified range combat enemy before. Let's go back to my handle events function, right? And from here, I'm going to go to get keyboard input, go to definition. And down in here where we had the fire the torpedo stuff, I want to grab this part, which is almost going to be identical for my other thing. And I'm just going to jump over to that spawn enemy torpedo, right? So here's where the spawn enemy torpedo is going to go. And it's going to look almost identical to the stuff we've already done, right? Except it's going to be torpedoes K dot pushback, a new torpedo K that's not just going to have a speed, but also a direction, right? That's what we need. So we're instantiating a new torpedo. As an example, we're placing it inside of I'm going to say that I'm going to get the position, and that's going to be equal to the spawn point in this case. All right, so that's the difference there. So that's the spawn point. That's the position where the torpedo is going to start. And I'm going to use the sound manager instance to play torpedo K as the object that I'm playing. And I'm going to add child my torpedoes K back, whatever that is, the last torpedo that I added in, right? So it's adding the torpedo to the scene. So all this is almost identical, right? And this is going to basically mirror what we did earlier when we pressed the button on our own, right? So this is our spawn enemy torpedo. Again, this is all prep for the attack action that we need to take in a second. Okay, so save, save. Awesome. And what we want to do is go back to that thing we were working on, we didn't quite finish, which is our range combat enemy again. Let's continue. So now going back to this, our range combat enemy is going to say, hey, scene, I want to get the target object, right? And it's going to give us information of what we want, right? So this is the target direction that we're going to pass in, right, to the torpedo. So we're going to say, get the target object, and we want to get transform dot position, right, minus my current position. Get transform dot position. That is my direction that I'm looking at. I want to change my current direction that I'm looking at. So I'm looking at, as an example, I'm looking at the actual the target that when I'm in range. When I get to range, I want to change my facing. So I'm looking right at the target, which is my ship. So I'm going to say, look where you're going, and I'm going to pass in the target direction right here. And there's typically right now there is no offset, but we can pass in an offset if we want. Okay, so look where I'm going. That's where I'm going to start looking. And what I also want to do is, here's the action to perform, right? It's going to be basically if, here we go, if m underscore fire counter. So this if fire counter plus plus, let's kind of increment it. If the modulus of that in the fire counter max, which is my delay, if that is equal to 0, so in other words, I've incremented my counter and I'm waiting. I'm creating a wait. So wait for a number of frames before firing. So this is equivalent to the your frame delay, right? I want to wait for X number of frames before firing. I'm going to say, hey, scene, now is a good time to spawn the enemy torpedo. Okay, so this is a way of doing it. Okay? It's definitely a way of doing it. It's not the only way, it's not the best way, but this is the way it's going to be done. And it's going to happen when I'm in attack state. Okay. So really, we needed to do this part only because I want to be able to face the enemy. That's what I'm doing. I'm facing where I'm looking where I'm going when I'm firing at them. Here is where I'm using looking where look where I'm going. And look where you're going is interesting because the way we're doing look where I'm going before, let's take a look and just to recall how that looks, right? It's really what we're setting up is the target rotation is a signed angle, right? We're kind of looking at how much I'm going to rotate. I have, I can set up things like a sensitivity as well as some kind of offset. I think Alex did it a little better here when he updated the whiskers and the way he ended up, kind of making an if-else statement to figure out how much I'm going to rotate, right, towards the target. So that's what this look where I'm going thing is doing. Okay, awesome. All right, so what I want to do here is, and when I'm doing this, it'd be nice if, this would all work properly. Let's see if this is enough to make things work. What do you guys think? Do you think I'm missing anything? Let's run this thing and see what happens. How about that? So we made some changes. We made changes to the placing. We made changes to the range combat enemy. And what we did with the range combat enemy is like, hey, if I'm in line, if I'm like kind of, if I can see my target, fire. Is it going to work? Is it going to crap out? What is it going to do? Well, let's take a look here in edit mode, right? Or debug mode. So I'm going to move this guy up and he can't fire him. But as soon as I go into firing arc, let's say somewhere up here, hey, look at that. It's going to fire its bullet, right? Why? Because I'm performing the attack action. Okay, what happens when I'm not attacking anymore? Does it go back? So if I move this out of range, he's going to basically keep going. Take a look there. He's going to go and he's going to kind of patrol. And if he comes into range again where he can see me, he's going to fire his bullet. Right now, he's going to stop right there because he can detect me. I'm in his radar, right? So his next thing is to move to the closest point where he's got arc. I don't have that action. That is for you to do. Move to line of sight, right, is what this guy needs to do, right? Or the other thing is, notice it says move to line of sight action. Okay, so that's what's supposed to happen. Let's put this up on GitHub because we've accomplished our mission. If we look here, we said range combat enemy. We moved all this stuff. We've changed it. We filled in the attack method. Let's commit this now, and we can do that. So we'll say something like clear git add dot git commit -m. We'll say added attack, or we'll say completed attack method of range combat enemy. Git push. Questions around this? I mean, again, there's a lot of things we can do here. Now we're kind of here, all right? So we've kind of done this piece, and we've added new torpedoes. We changed it, all that kind of stuff. So I can move IM GUI to get the enemy within range so that this is going to fire, which is what I did. Here's for you to do. Let's think about some things that you can do to make this better. And this is kind of part of your lab. So one part of it was you and I do together, and the next part of this lab is you do by yourself, okay, to make this work. So one, rework the torpedo classes like we said. So right now there's 2 torpedoes and they're almost identical, right? How do I rework these things? So I have a torpedo superclass that, let's suppose Torpedo Federation and Torpedo Klingon being the Torpedo K guy, the green torpedo from the bad guys, and Torpedo Federation is the good torpedo from the good guys, right? The nicer looking one, or whatever, the other type, I don't know. How do I do this, right? And it says we want 1 vector of torpedo pointers, which is the base class. We've done this before, right? We have. And for collision testing, you can use a dynamic cast to test which subclass is actually pointed to by the torpedo. Right now, we haven't done any collision detection at all. How would Collision Manager work? Well, what shape would you assign to the torpedo? Let's take a look. So if I was to go to the torpedo, right, and we looked at our assets, let's go to asset sprites. And if we go back to that torpedo, let's suppose it's the torpedo K that we're going to think about. What collider or collision shape would you give to this torpedo? What would you say is the right collision shape for it? What are your thoughts? Because this is part of what you need to do for your assignment 4, right? When you fire bullets and stuff like that, right? Because it's got to be range, some kind of range something. Come on, guys. What collision shape would I use? Because whenever I do collisions, I need to do some kind of overlapping, typically, right? Vander says a circle. We could, right? Because you can make it so that if I used a circle, that's definitely 1 because it's kind of circular. And the circle, if I was going to draw it here, let's just use the ellipse tool to draw it here in my drawing tool, right? What I want to do is I want to draw a circle that is 64 by 64. Or width and height is 64 by 64. That is the circle size. This is kind of what it's going to look like, just so we can visualize it here. Let's make it so that it's transparent, and we'll give it a bit of, kind of a shape to it. And that's kind of what it looks like, the torpedo. But I mean, if you can see that the torpedo as a circle, not bad, right? And the good thing about it is you want the collider or the collision shape to kind of encompass the entire object as much as possible. This is pretty big, right, for the collider, right? So take a look. I could make it this big, right? And you can see here I got this little piece of the torpedo that would fill in. But, guys, I don't have to make it this big, right? I could also make it a lot smaller, right? So let's say I want to resize this thing, and let's make it so it's much smaller, something that is only the size of the actual object here, like this. That could be the size that's reasonable as well. And that's something like 20 by 20, or even something smaller like 10 by 10. Let's see, 10 by 10 works. 10 by 10. Right, so it's pretty small. Maybe not too big, but that's kind of the size of my collision shape, because it kind of encompasses. Let's make it a different color so you can see it. We'll make it red, right? And we'll make it so it's a couple of points, pixel points, so you can see it. So that's kind of the size of that little place. The other parts are like the sparks that come out of the torpedo. But the actual torpedo itself is right here. Look, it's almost in line with everything that's happening, right? So here, for this torpedo shape, it'd probably be a circle. It could also be a square. Like if I wanted to, because it's so small, and now you're going to say, well, it's not accurate. Guys, for this shape, a bullet that's firing this big, you're probably not going to tell. Remember, it's always what is good enough. Sure, a circle is more accurate, but at the end of the day, it's much lower. It's less computationally expensive to do either a circle or a square. Circle requires distance calculations, where we do whether it's a squared magnitude or an actual distance. We don't want to use the distance because we're using square root, so we'll probably use square magnitude to figure it out. So that's definitely something we could use as well. We can always use a square collision shape because it's so small, and probably you're not going to tell, right? Because it's so fast. And that's what game development's all about. It's doing what's good enough, not what's perfect. And usually what's good enough is actually less computationally expensive than something that's perfect. For example, perfect collision detection, pixel perfect collision detection is not always what we want. Okay, it's not required. Okay, so that is something that we can definitely do for the when we kind of think about collision detection for our torpedo. So that's one thing we can do. And then when we do collision detection inside of our object, and I'm just talking now, the lab for me is done at this point, okay? But I want to talk about the other things to do, right? For your assignment 4, right? Let's take a look at our collision manager. Our collision manager has a bunch of methods that are static that you can use. So example, AABB check, right? Line AABB check, and to Vander's point, a circle AABB check, where one of them is a circle and the other one is an AABB. It's totally up to you. You can make your own too, your own collision detection, and you will next semester in physics. You'll make your own collision detection algorithms, right, that do different things than these, right? But at the end of the day, these are perfectly fine. So a circle AABB squared distance, right, calculates the squared distance between a circle and an AABB, which is used by the circle AABB check. Let's go to definition and see that. So if I was going to use that circle idea for my collider shape, my collider shape being a my circle AABB, then if I go through here, you can clearly see if I scroll through. Here we have our box width and our box height and our half box width and our half box height. And what we're doing is we're calculating the common properties for both. For object 2, which is the AABB, and for object 1, which is our circle, right? And then we're using a circle AABB squared distance check to check if I collide. So now we get to this point where, yes, we've collided in this case. In this case here, this if statement, like, yeah, we're colliding. We're definitely colliding. All right, good. So now there's the type. If the type is a target, as an example, then let's play the yay sound, right? And if the type is a ship or something else, let's play the thunder sound. And you can make whatever cases you have to do. This is where you customize your collision manager so that the colliders work. That's how you make it work, okay? Derek says, can I add a vec2 named m_checkbox and write a setter and getter and set the collision range by setter and check the collision from getter, not the position? Checkbox. You mean like a collider? Yeah, I mean, there's lots of ways to do it for the torpedo superclass. Yeah, I mean, Derek, it's up to you how you write the torpedo superclass. Where you want to check to see if if you want to set whatever the collision range is, you want to do collisions with the torpedo itself, you can. But the collision manager does it all for you, right? So, again, it really depends on what you're setting up. Circle AABB check. So let's do it. If I did a circle AABB check really quickly, just going with Vander's idea, where the circle is the bullet and the AABB is the object, like the target, and we'll make a sound. Okay, so if the target is the one we hit, we'll make a sound, like an explosion sound. We'll call it thunder. And we'll say that, I'm just modifying the collision manager here, where it's a circle AABB check. This is not part of the lab. Okay, I'm showing you what you could do. And here we want a collision with our target is what we want. That's the collision with the target. So this is going to show us it collides with the target. And the sound manager, it's going to play a sound, right, that we want to play called thunder, right? Well, thunder has been preloaded in our play scene. If you look at our play scene, you can see that thunder sound, which is that weird sound that you can make with your lips to kind of mimic a thunder sound or an explosion. That's what it's going to play, thunder og, right? And that's what the collision manager is going to do. It's going to play the thunder sound because the sound manager has that loaded in, right? And that's what's going to happen here. We can get rid of this other stuff. The ship is other stuff. We don't have a ship right now. We have something else. I'm just going to get rid of all the rest of this stuff. So this is the other case. By the way, notice you can put curly braces around the case so that you can stop any leakage of variables, right? So example, I have a case, which is my target, and I could put curly braces around the case inside the particular case. So I can say, okay, for this target, I want to do this. It's a good practice to do that anyway. Because what I'm doing here, when I have curly braces in C++, I create a scope. That's what I'm doing, right? So that is kind of an easier way to doing things. All right, good. So if the thing that I'm colliding with, if my object 1, so look what I'm saying. If my object 1 is the target, no, it's circle AABB check. I'm checking to see if my object 1, right, and my object 2, if my object 2 is the AABB, that's what I'm checking. So it says, hey, this is how the check works. Okay, just to show you. It says, if I'm looking at my circle AABB squared distance, this is what it's doing, right? So that's how it starts off. If my circle AABB distance between the circle center, which is the circle center, remember in common areas is my object's one circle center and, right, circle radius, my box start, which is the starting of my, of where my AABB starts for object 2, right? And the object 2 width and height, if this is true, and if it's less than the circle radius times the circle radius squared, basically is what it's going to do. If this is true, we have a collision. And if the object is not already colliding, then what I can say is, okay, if my object 2, which I want to check, not object 1, if my object 2, the thing that I'm already connecting with, right, if it's a target, then play the thunder sound. That's what I'm going to do. If object 2 is the target. Okay, cool. Where object 1, in this particular case, would be the bullet. A bullet's going to be a circle, and the target is going to be an AABB, which is going to be my ship. Okay, how do I use this little check here now? In my placeScene.cpp, right, we're going to go to the update method, right? And in the update method, we have a bunch of this, right? And we're going to basically say, okay, for every bullet that has been fired by the, as an example, for every bullet that's being fired, by the ship, the enemy, check to see if there's a collision with the target. So the way I would do it anywhere around. So collision check, from between and the target, right? So how would I do that? So say, hey, collision manager, I want to do a circle AABB check where the target is one of my torpedoes. The object 1 is one of my torpedoes, and object 2 is M_P target. That's what I want to be able to do, right? And that is going to create a AABB check. That's what it's going to do for me, okay? Circle AABB check. I need, though, the first part, which is the target, and I can do a for each loop or a ranged for loop to do that. So I can say for each, and I can look at for every inside of M_torpedoes K, for every torpedo in the torpedo K. So for every torpedo K in torpedoes K, for every Klingon torpedo, the bad torpedoes, I want to do a collision check, right? And I want to do a collision check with the torpedo K, right? And my target. Now, this torpedo K, because I'm saying that there is a circle and the torpedo K is 64 by 64, wow, that is an issue, my friends. It's a huge issue. And it's a problem because my circle AABB check, remember that little diagram I had? It's going to check the entire object that I'm colliding with, not just the small little part of it, right? So it's not going to look exactly right when I do it this way, but it's going to do the check for every torpedo in the scene that's being fired at me from the enemy. Let's try and see if this works and if I did it right. And if I didn't, we'll go and fix it. Again, not really part of the lab, but I want to talk about it because I want to explain how this might work. Okay. So again, we have our little guy here, and I'm not going to turn it on for now. Let's just kind of run the target so it's close, and let's see what happens when I fire, right? Does it fire? Am I in range? It says, no, we're too close. Move to range action. So let's move our ship farther out, and there you go. Whoa, what happened? How come it's making that sound? It says no free channels. Wow, so that's not really working out the way it's supposed to, right? So I'm checking to see, here's something interesting. If I go back to my collision manager and I go to my collision AABB check, it's saying if my object 2 is not colliding, then make the sound, right? Well, it's not really my object 2 that I care about, is it? Not really. By the way, there's also other stuff here. It says attack vector is this, And let's do a dot product of the magnitude and all this kind of stuff, right? I really don't need any of this stuff, really. The attack vector, what am I doing with the attack vector? I'm not really doing, well, anything, right? That's the angle of the, thing. So none of this is ever really used. The dot product uses the attack vector. So all this stuff may have been used somewhere else, but I don't need this stuff right now. And if we look at it, let's keep going with this, right? So we know we can detect collisions because we're saying, hey, if object 2 get type is the target, but we want to make sure that object 1, which is the bullet, is not already colliding. If it's already colliding, don't make a sound. Make sense? Because we only want to make a sound one time, right? Otherwise, this is going to keep making the sound like we heard every single time. So we're going to check to see if it's already colliding. And if it is, then we don't have to, we'll skip this whole part. If it's already colliding, that means we're already made the sound once. We don't want to make the sound more than once. Okay, cool. Let's try this out and see if that works and see if it's any better. Okay. So again, we'll set it up the same way. So we'll say that here it is. And let's move this part over here this time. And we'll move this over here. It missed. But now we're detecting collisions early, right? Okay, collision with the target. Make sense? So yeah, this can work. There's problems. Okay, a couple problems. One, our circle AABB check is assuming that we want the entire circle to be whatever the radius is that we want. Okay? We could change this circle AABB check to also have an optional radius for the circle, right? And also an optional size that we want to preset for our object 2's bounding area, like our width and height, because we can adjust the width and height if we want to. Here it's automatic. We automatically find the width and the height of both things. So if I wanted to make it tighter, I can have a circle AABB check that also takes in an optional value, like for example, an optional circle radius, as an example. And you can put that somewhere else, right? So there's things that they can be improved on. Unfortunately, we've run out of time, but that's the only thing that we had a chance to check out. I'm just going to put this up on GitHub. So I'm going to say git add dot git commit -m, and we'll say, added collision check with, kind of Klingon bullet. Torpedo K. Git push. Okay, you have all that now. So Derek asks, can I add the virtual on collision game object collider method for game object, and when collision happens, the check function will do, the check option will do game object 1 on collision game 1, 2, or game. Yeah, I mean, it's really up to you how you want to do it. To me, I use a collision manager to handle all collision types, right? That's just me, what I do. What you're talking about is this, you want to add an on collision to the object itself. Yeah, you could do that. So the on collision method itself, maybe you run that every update. You have to check every update to see if it's colliding somewhere, right? Maybe you run that inside of the bullet collision part, if the bullet collides, not inside the scene. I'm running it here in the scene. You can make it part of the bullet. Yeah, absolutely, you could do that. All right. Okay, so that is what we want to talk about. One more thing. So we talked about you want to, instead of move to player action, really what we want to do is move to line of sight is what this is going to be. So sorry, don't do the move to player. It says move to player action for the close combat enemy is what it's asking you to do, right? But and that's something that we haven't really talked about. We haven't really done anything about the close combat enemy at all, right? The close combat enemy, if move to player means it's going to move right to the player itself. So this is kind of different than what I've asked, right? I mean, things to think about is, how do I move? The easier one is move to line of sight. How do I do that? That's the easier one. This is more of it might be more difficult to do, right? I want to use seek, right? but I want to avoid colliding with my obstacles, right? So this is something that you may want to do as well. All right, think about that, right? Because at the end of the day, if I seek towards the closest target, the closest path node with line of sight, if I seek toward the closest one, I'm going to cut right through my obstacle. I have to kind of create a path, right, to go there. And we haven't really talked about how to do that. So again, if I was to run this thing, let's just do this for a second. If I was to run this thing, and if you look at the grid, you can see there's a grid of tiles here, right? And these grid of nodes is what these things are. So here it says perform move to line of sight action. Where would line of sight be? Well, maybe the closest line of sight point to the player is this one. That's the closest one. Or maybe this one, right? Notice that it's pointing right here. I can't go here. I'm going to go right through this obstacle, right? So I need to find a pathfinding. Remember we did this before, where I have the closest node to this, right? Remember I have line of sight only to the target, line of sight to the starship, only to this part, line of sight to both the target and the starship. Okay, that's what I want. So line of sight to both the target and the starship, which is this one, and this is the closest node. So if I was to move, if I did it for you, and I move this across, it would be like this. Look, right? He's going to target and do this. Okay? Notice also something else. When I'm firing, my line of sight changes too, right? It's almost like, and this is bad, this is another bad thing. When I'm firing, because I'm not ignoring the bullet, right? I'm losing line of sight. And that's why it's sparking that way, right? So other things to think about as well. Remember that when we calculate line of sight, where do we do that? Do you remember? Is it in the placing? Where do we do that? Well, here it says, I want to check all nodes with target. I want to check all nodes with a target spaceship or target or both. That's what this is doing, right? So if I go to check all nodes with target, go to definition, right? Check all nodes as target, checks line of sight, path node, go to definition. And what this does for the path node line of sight, it's basically saying, hey, check path node line of sight, it's going to check agent line of sight, go to definition. Check agent line of sight, we should not be blocked, right? It should not be blocked by, look, it says it's not this type, and it's not path node types, and it's not the target itself. No, we don't want that either. So none of those are true. Well, you know what? It's not a projectile either. We can put that in there too. So we can say, and display object, you know what? If you really want to put this list on, it's not equal to the game object type projectile, right? We don't want that either, because if it's a projectile, we don't care. That doesn't make sense. Why would I be blocked by my own bullet? So I don't have line of sight anymore. So save. So it's not, projectiles now will not bother me anymore, right? Yeah, hold on a second, Derek. Let's go back to that second. So if I run this again one more time, and now that I've made that simple change to the check agent line of sight, it's going to ignore my bullets as well. So let's do that. So, yeah, we'll say this is, I want both. Let's see how it looks. So this is the only place it can move to. So I move here, right? I turn and look, now I don't lose my line of sight because of my bullets. Otherwise, I would have lost them every time, right? Okay. There it is. Nicely working. Okay. But what if my ship moves out of target range? I move over here, right? Now this thing has to be back to performing move to line of sight. So now you have to program this to move to line of sight again. So Derek had a question. Derek says, I'm wondering if I move to cover because it is not only the point out of the target line of sight, but also the point after the obstacle. Well, let's think about this. So if you're moving to cover, okay, question. If I turn this on, is this in cover. Look, so here, right here, this is this in cover. And remember that it's this showing both target and starship for line of sight, right? So if I move my little ship here, right, and let's move it right here, I'm still in cover here, right? That's what it's showing, up to about right here, right? Up to about right here. That's kind of what cover is, right? So it's kind of funky when you move here. Like it's actually going to move to this little point here. So it's almost like I got to move it to, sorry, it's kind of trying moving itself here too, right? To this point, right? That's what it's kind of looking at. It's kind of moving to a place where I'm behind cover. Is this behind cover, or because here, look, my ship can't see, right? Because these nodes here are showing that my ship can't see this already, right? If I move my ship like over a little bit, then all of a sudden now I have the ability for me to, I'm too close. That's what this is saying. That's why it's not triggering, right? But if I move to to line of sight, right? So again, let's do the action. So I'm going to say I'm going to do some damage, right? The starship's down to 75%. I do it again and again, and now performing the move to cover action. It says, right? It said it a bunch of times, and now it's going to do the flee action when I got hit. Both those actions were triggered. The move to cover action and the flee action, right? So now it's going to run away. If I reset, if I press the R button, it resets everything, right? Now it just says move to range. I'm too close, right? So let's move it to range. So let's move it up. And let's move it over here. Now I'm in range, right? Now it says performing the attack action again, right? So to go behind cover, if I press K, it should pause. It should pause my action, right? Move to cover action is something that I need to do. And when I'm there, I have to wait behind cover, which is not what's happening. So I got to move behind cover somewhere where there's no line of sight between me and the enemy, which is in this case the player. But I may still have, I don't care about the radius. All I care about is that I'm behind cover somewhere where I can wait and hide, before my this ship goes there. And I'm probably going to get to cover by looking where I'm going. I'm going to plot a path to the closest node that doesn't have any line of sight to me. Remember, we kind of got you to do that in one of our labs. In lab 7 part 1, we said plot a path between yourself and the closest node to you, right? That has line of sight with the kind of with the enemy. So certainly we can start programming these kind of things. But the idea is it's very simple. So Derek, yeah. If the distance is longer than the target line of sight distance and ship line of sight distance, even if it's behind cover, it can still suit the condition. Yeah, so you got to figure that out. You got to make it so that you don't want that to happen, right? If it's behind cover, if you're waiting behind cover, you don't care about the other conditions. You're waiting behind cover. And you're going to stay in that condition, wait behind cover until wait behind cover is gone, right? So if you want to check to see what state I'm in. If I'm in wait behind cover, I'm not going to check any other states until I'm done waiting behind cover. Now I'm ready to go back into the fight again, right? So you have to make other things, other kind of conditions to get me out of cover again, because when I'm done waiting behind cover, what do I want to do? I've waited X number of frames behind cover. I went behind cover. I ducked behind cover so I don't get killed, kind of thing. And then I'm going to go back to seek line of sight again, right? Depending on where I am, I'm going to go back into the decision tree. But until that point, my wait behind cover is going to kick in. It's going to make me wait there until it's done. To check this, always check your document, right? So one thing we just talked about a bunch of stuff here, but if I go to the document, let's check this out for a second before we go. I know we're running over time, but I just want to discuss this with you because I know the assignment is running close, right? So here's assignment 4. And then I'll take questions from everybody else that's here as well. I know there's other people that are waiting for me, so please bear with me. Why is it doing that? It's like it's recovering files. It's really weird. I had this funky computer crashed lately, and I had a couple of other documents up, and it's just bringing them up every time. All right, so yeah, so let's take a look here. Just want to drag this, and we'll just go do one of these. There we go. And so it says, okay, it's due Sunday. Right now it's due Monday, actually. I moved the due date. Just keep this in mind. It says that if I am move behind cover, it says find the closest node to the player that does not have line of sight and move there. Play the move animation and related sound effects. Okay, cool. When I get behind cover, so I'm now behind cover, there's going to be another state that's going to be like behind cover. I'm in behind cover state. Okay, if I'm in behind cover state, the enemy must be behind cover, right? And I'm going to perform the wait behind cover if I'm in behind cover state, right? Like if I'm in that state. And the enemy will wait for a random interval and then leave cover. Okay, leave cover means I'm going to go back to combat state somehow. You need to kind of have those two states in mind, right? Where I'm done waiting behind cover. Now what am I going to do? Well, guess what? I'm going to go back to my decision tree again. Okay, so where am I? That's what I'm going to do here when I leave cover. Back to my decision tree means that if I go back to what I had before, so let's go into this for a second. Let's do that diagram, right? Always refer back to the, to your stuff, right? So if I go back here, I'm finished moving, I'm waiting behind cover, I'm done, right? So look, it says set detected to true. Could be static or some kind of bool. If I'm waiting behind cover, I'm done. I go back to the top. Is my health less than 25%? No. Is the enemy hit? Right? Did I get hit still? No, I'm not being hit right now, right? So what am I going to do? Is my player detected? Are they close enough so they're still in my radius? It's true. Do I have line of sight? No. Move to line of sight. Probably is the next action I'm going to do. Move back out and see if I can see him again, right? And then if the enemy can see you, guess what's going to happen? It's going to go back up to the top here after it's performed that action, right? And it's going to go, do I have line of sight? Yes. Am I too close? Am I within range? Okay, well, move to range. Find a good spot. Far enough away that I have line of sight. Move to range might be something like, and again, let's take a look of what it says in the documentation when it comes to move to range. Let's go back to that, sorry. So move to range requires line of sight. I need line of sight, right? Some place where I have line of sight and I have some kind of optimal distance between, you decide what that range number is, right? I put a number there already for you, but you can change that to whatever you want. And when I get to that particular optimum range, then I want to, I go back to the diagram. I'm already within range. Within range is true. Fire, 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 fire. Keep firing over and over again. It's going to go through the decision tree every frame and keep firing until something changes. That's how it's going to work. Okay? Okay, any questions around this before we move on to other things? And I can stop recording. But I'm taking these questions because I want to, make sure I answer most of these for you. Okay, so let's stop this. I'm going to stop recording. Thank you so much, guys, for attending the lab. Remember, class will be on Thursday. I'll be talking about a new topic, and I'll talk more about assignment 4. Okay, so that's what's going to happen then. Thank you so much again. I put everything up on GitHub, I think, and I actually made one change, which is what I want to settle. Just 1 second here. So I know that I did one more change. We'll say a git add dot git commit -m, and we'll say set line of sight to ignore torpedoes. Git push, because otherwise it's going to always change the line of sight. Okay, yes, we can do that, no problem. All right, so that's this done, and that's it for me today. Thank you so much for attending, and I'll see you guys on Thursday, and I'll take some questions for the people that are waiting around for me now. Okay.